Welcome. In this video, we're going to talk to you about how we can estimate some square roots. The last 2 days we've worked with square roots. All of them have been perfect squares. We're going to look at the objectives to learn what a perfect square is today, and then understand how to estimate the square roots that are not perfect squares. Perfect squares are those numbers that are made by squaring another integer. If I do 1 times 1, I could get 1. If I do 2 times 2, I'd get 4. 3 times 3 makes 9, and so forth. These are important numbers for us now because the square root of any perfect square is always going to end up being an integer. We know from today's key terms that an integer, that just means a whole number, the positive or the negative version, and it includes 0. Now, not every number is a perfect square. If we look here, we can see our table of perfect squares that we're going to work with more. There are a whole bunch of numbers that fall between 1 and 4, or between 4 and 9. Any of the square roots that are not perfect squares, their answers are always going to be irrational numbers. We're going to get into that more, but an irrational number, that means a really long decimal, it never stops, and it has no repeating pattern. The square root of 2 would be 1.4142136. It would keep going, and we see some other examples of irrational numbers today. For our first example, we're asked, what is the value for the square root of 5? Our first question might be, is the square root of 5 a perfect square? Turns out the square root of 5 is not a perfect square. There is no number times by itself, no whole number times by itself, that would ever give us 5. So that tells us the square root of 5 is going to be some kind of irrational number. No whole number, but we can estimate the answer. Go ahead and pause the video and think, how can we estimate the answer of the square root of 5? Welcome back. Hopefully you came up with the answer. The square root of 5 is somewhere between 2 and 3. Here's how we could realize that. The square root of 5, if we look at this number line we've built here today, the square root of 5 falls between the square root of 4 and the square root of 9. It would fall somewhere right in here, square root of 5. Because of that, we know if the answer for the square root of 4 is 2, and the answer for the square root of 9 is 3, the answer for the square root of 5 is between 2 and 3. It's going to be 2 point something. We could say maybe 2.1 or 2.2. It's something that's going to be pretty close to 2 because the square root of 5 is very close to the square root of 4, but just bigger. Go ahead and pause the video now and try to estimate the next two square roots, the square root of 20 and the square root of 183. Welcome back. For the square root of 20, you would see again it's not a perfect square. We're going to get some kind of irrational number, a long decimal answer. If I were to place the square root of 20 on this number line, it falls between the square root of 16 and the square root of 25. So we can place it right there. And that tells me if the square root of 20 is here, the answer is somewhere between 4 and 5. For the square root of 183, it's a lot bigger. You'd have to know some of the bigger perfect squares, but if we know 13 times 13 makes 169, and 14 times 14 makes 196, then we know the square root of 183 would sit right here on the number line. So the square root of 183 would end up being somewhere between, mess that up a little bit, we see the square root of 183 sits between 13 and 14 on our number line. So the answer might be something like 13.5, 13.6. We'll talk more in future days about how we can get a better estimate than just between 13 and 14.